there is more to discuss with this bugger called secondary index. Cassandra previously didn't have this concept of secondary indexes, but now they do, and in the upcoming versions you can also expect materialized views and stored procedures in Cassandra from Cassandra 2.2 or 2.3 or whatever. With 2.1 it is not there yet, and that is going to open a big hell. I will tell you why. Because every time you want to, let's say you have a data model, you have a table with certain columns, and then you suddenly want to query on a particular column, which is usually going to require you to create another table with that as the partition key or a clustering column so that you can use that in the var clause. But you don't want to do that. So what you do is, hey, why am I going to create another table and then replicate data? So they say, you know what, we're going to create an index. And that is where secondary index comes into play. It's just like a plain old index, but the difference here is if you, let's say the data is distributed. In Oracle, it's very easy, right? All the data is in one central place, or just not Oracle, any other RDBMS. So data is in one central place, and you hit one index, the result gets out very quickly. But here the data is distributed across the nodes. Not one central location can give you the results. So when you're actually using a secondary index, imagine you're going to hit the index across all the nodes in your cluster to actually give you the result of that query, and that is a performance killer. So then you're really going to regret why you started using Cassandra in the first place, because imagine if Apple started to use secondary index on their iTunes cluster with 74,000 nodes, it's going to sit down. And I know that Netflix uses more than 30,000 nodes per cluster. So that's just terrible. It's just going to hit all the nodes, and you are going as a client to wait until all the nodes give you, or well, if there are 30,000 nodes and the replication factor is 3, then you're going to wait for a response from 10,000 nodes.
Couldn't they just store everything double then? So one for the first indexing, one's kind of node scheming for the first index, and another replicated with fit for the second index?
Yes, but the classical problems again comes into play. Every index is good when you are doing a lot of read and not writes, but Cassandra does a lot more writes compared to that of reads. That's where it best fits in, and then you have to constantly update all those indexes. Actually, I'll tell you why it came into play. And Cassandra, if you talk to one of the salesmen from Cassandra, they will ask you to use DSE. DataStax Enterprise has 2 clusters, and they like to use this term love triangle, right? With a love triangle or DataStax Enterprise, what they mean is that you have a first cluster running the normal production version of Cassandra, and then you have a second cluster running the analytics bit. And the analytics bit is running Spark, right? And then it just doesn't run Spark, it also runs Solar. Solar is just a wrapper around Lucene. If none of you, well, if you know, good. If not, it's just a very simple explanation of wrapper around Lucene so that you can do Solar or Lucene queries and then retrieve results very quickly. It's just very neat in that respect. But the way it actually works is that if you are going to do that in a second cluster, it uses secondary indexes heavily because they want to have, well, Spark SQL queries, or you can write those Solar queries. I don't know what exact query syntax is, but because I'm not a Solar user, but you can actually write those queries and then query data within Cassandra, and they heavily use secondary indexes. Yeah, that's how Spark SQL works in the Apache cluster, in the analytics cluster, which is good. But when your data grows, then you're going to pay a very heavy price. Anyway, so how to actually, if you are still going to go and create a secondary index for whatever reason, this is how you go and create it, and that's how you drop it. Okay. Oh, sorry. No, that's not it. Damn. Sorry. Okay. When to use it and when not to use it. So if you have a low cardinality column, probably secondary index is not a bad idea. And obviously, if your columns have very high cardinality, don't use it. And never use secondary index on counter columns, because yeah, it just counter column is supposed to be like one counter value per cluster. It just doesn't really go well. And I guess that's it. I pretty much covered everything. Next comes user-defined types. This is the question that you asked, well, how if I want to use one collection type within another collection type, if I want to use sort of recursive collection types, then probably your choice would be a user-defined type. It's just like in any other programming language. Yeah, the way you create a user-defined type is not very different from the way you actually create a table. It's just that you don't have this primary key or clustering order by clauses. It just you leave those two bits, and this is how you define a user-defined type. And you always have to use this keyword frozen when you use a user-defined type. There's another big explanation on why you have to use frozen, but we'll just leave that out for now. Then comes tuple. Tuple is also another place where you can sort of nest a collection within another collection. But tuple usually takes, you just, let's say if you want to record like a series of numbers for whatever reason, then you use tuples like this. But with tuples, you pay a higher price, because every time you fetch a tuple, you're fetching the whole value. You cannot actually, when the way you actually store it is, this is stored as one unit. It is not with the other column. You can just retrieve one particular value. Here you retrieve the whole bunch, so that is the drawback of tuple. But tuple is another bit that you can use, and that's the limit, and the limit's a lot lesser for tuples. Okay, last and the most important bit, batch statements. Well, obviously you're not just going to perform write, update atomically. You want to perhaps club all these things. And that's where batch comes into play. You start a batch by saying begin batch, and then you say apply batch, and then it'll all be treated as one single logical operation. But, again there's a but, there is no transaction isolation, which means as you're running this particular statement over here, someone else, like you are in the middle of doing a batch, another client sends another query, another transaction comes in, so you don't have the classical transaction isolation, number one. Number two, there is no guarantee that this batch will actually be executed in this particular order. Cassandra will decide whatever order that it will feel that it is fit. So if you run this batch like 2-3 times, in each and every execution, the order will be different. And obviously you don't have transaction isolation. So if you want to do all that, well, yeah, and batches are not atomic. Sorry, it is atomic. Sorry, my mistake. How you can actually apply what then you can do is, that's not right, sorry. Batches are not allowed on counter columns, but if you do this, then you do allow batch operations on counter columns, but then the atomicity that you had previously, that you're going to lose when you do this particular operation.
When you say that the order is whatever the execution engine wants,
this one, right?
Is it defined?
No, because you have to understand you're dealing with a distributed database, and you will have no guarantee that which of the statement within the batch will be executed first.
But if you have two that have the same primary key, a delete and an insert for the same primary key?
Well, from the product they said there is no guarantee.
So it might be deleted, it might be inserted.
Yes, but you don't know if the delete will happen first or the insert will happen first. Yeah. Maybe in the first time the delete will happen first, and in the second execution the insert will happen first.
The result is unknown.
Yeah, and then maybe you can also use that, here I have not used any LWT, and if I use the LWT, then you have more problems. Sometimes the batch will work, sometimes it won't work, and it is the same batch.
It's a little like Schrodinger's cat.
Yeah, and then yes, here comes the lightweight transactions in a batch. So now this batch will execute only if all the conditions for the lightweight transactions are met, and this will also execute the transaction serially, but it is a big performance killer if you want to do that. And if you are going to execute this kind of query in RDBMS, RDBMS is a lot faster to execute these kind of queries. This really staggers, and if you're writing a production grade application, you will most probably bump into these kind of queries, and then the Cassandra consultants will come and tell you that you have modeled your data incorrectly, and then you have to remodel your database. Well, normally, so this is the last slide, which is the good news. We can all go home after this. You get the logical data model, and then once you have the logical data model, you work with that logical data model using the application workflow, and then move to physical data model, not the other way around. That's the bottom line. You shouldn't first start with the data model and then try and think of application logic. No, think of application workflow and then go to the data model, from logical to physical.